Okay, first problem on the Test 5 study guide. Only 18% of the reception guests were uninvited. If 1,476 of those present had been invited, how many guests attended the reception? So the first thing I notice here is we have uninvited and invited. Also, I've got percent of making a part whole problem. So, they're giving me the parts with invited and uninvited. And if I start off there, make the chart, percent actual. I'm going to put invited and uninvited as my categories, as my parts. My whole, if we take everybody who was invited to everybody who wasn't invited, put it together, that's everybody who was at the party. So we can get an idea of where things go. So 18% of the reception guests were uninvited. So 18% goes in the uninvited column. And the way parts work is parts add up to 100%, which means if 18% were uninvited, that means 82% would have been invited. Add those together, we get a total of 100% for all the guests at the party. The next thing says 1,476 of those present had been invited. Okay, that's not saying 1,476 people were at the party. They're saying 1,476 people at the party were invited. So that goes right here. And the question then asks, how many guests attended the reception? That would be the total number of guests. That's what we're looking for. So the uninvited number was necessary to get the 82, but at this point, uninvited is not going to help us get the right answer. At this point in the problem, I'm going to take the chart to create a nice proportion. 82 over 100 equals 1,476 over x. And since we have calculators, it's easy enough just to go ahead and do this. So 82 times x, and then 1,476 times 100. And obviously to get the answer then, 82x equals 147,600. We divide both sides by 82. Get our calculator out. Type it in. Comes out to 1,800 people. So there are 1,800 guests at the party. If they had needed the uninvited, we could just subtract 1,476 from that to get that 324. You know, obviously we could have, if they wanted it uninvited, we could put the x here instead of there and then a proportion of that. But again, just look at the problem, look at what it is. Percent of is always part whole. Identify what the parts are. Usually it's something and not that thing, so invited, not invited kind of thing. Example 2, solve a linear system of equations. I think the preferred method for everybody is the elimination method. It's set up best for elimination, so I'll go ahead and do it that way. For me personally, I like to get rid of the ones with opposite signs already, even though 3 and 5 are bigger than 4 and 2. Just the fact that they have opposite signs means I don't have to multiply by any negatives, so there's no sign changing going on. It makes it a little bit easier in my opinion. So I would take the top equation, multiply it by 5 to make this into negative 15y. Take the bottom equation, multiply it by 3 to make that a positive 15y, therefore canceling those two things out. So 5 times 4x is 20x. 5 times negative 3y is negative 15y. 5 times 17 is 85. 3 times 2x is 6x. 3 times positive 5y is positive 15y. 3 times 15 is 45. Be careful that every single number gets multiplied. The most common error I've noticed is people will do this and this, but they'll forget to do that. So be careful that all three numbers get multiplied. And again, make an intention when you do this. My intention is to get rid of these guys. Now I can because they're opposite signed objects and they're opposite numbers. So if I add the equations together at this point, 20x plus 6x makes 26x. Negative 15y, positive 15y cancel. 85 plus 45 is 130. We divide both sides by 26. That leaves me with x equals 5. Once I know what x equals, then I go back to find y. I would personally go back to this equation here because everything's positive. Again, the less negatives in a problem, the easier they tend to be. So if I change x to 5 up in this equation, It's going to be 2 times 5 plus 5y is equal to 15. I don't know what y is yet, so I can't replace it with anything, but I do know that x equals 5, so I replace that. 2 times 5 is 10. Move the 10 to the other side. Change the sign because we moved across the equal sign. It gets me 5y is equal to 5. And then divide both sides by 5 and get y equals 1. On homework, a lot of you are leaving your answer like that. I am expecting an ordered pair every time, so make sure that you leave your answer like this. An xy ordered pair. X goes first, y goes second. Make sure you're labeling answers on your paper so that you know where they belong in this ordered pair for the final answer. In example 3, or number 3, it's the same kind of problem. I'll go through this one a little quicker. I would probably get rid of the y's again just because of the opposite sign. So this times 7, this times 2, negative 14y, positive 14y. That's my intention. That's what I'm going to have happen. The consequence is that 7 times 7 and 25 times 7 are going to happen. So 7 times 7x makes 49x. 7 times negative 2y, negative 14y. 7 times 25, 175. 2 times 4x is 8x. 2 times positive 7y is positive 14y. 2 times negative 2 is negative 4. Pay attention to signs as you do it. Make sure that you get the correct signs in all your answers there. And then 49x plus 8x makes 57x. Negative 14y, positive 14y being opposites cancel. And 175 minus 4 is 171. We divide both sides by 57. That leaves me with x equals 3. Knowing that x equals 3 just allows me to go back to one of my equations and change x to 3 and solve for the other. So 4 times x, which we're replacing with 3, plus 7y equals negative 2. 12 plus 7y equals negative 2. Move the 12 to the other side, change the sign. Same sign is going to add them together. And divide both sides by 7. Gives me y is equal to negative 2. And again, once I know both x and y, I want to write my answer as an ordered pair. X first, y second for my final answer. Number 4, one last system of equations. This time, these are the same sign, these are the same sign. It doesn't matter about these really, but as far as my letters are concerned, the letters both have the same signs. So there's multiplication by negative required in this problem. Probably the easiest technique here, that's 4x. I'm going to make this a negative 4x. So I'm going to multiply the top equation by negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3y makes positive 12y. Make sure signs change when you multiply negatives. Negative 4 times negative 17 makes positive 68. So now I've got, instead of that equation, I've got these two equations. 4x minus 4x cancels. Negative 7y plus 12y makes 5y. Subtraction because the signs are different. And positive because 12 is bigger than 7. 68, negative 38, again opposite signs, so I subtract. 68 is bigger than 38, so we make it positive. 5y equals 30, we divide by 5. That gets me y is equal to 6. Once we know what y equals, I can go back to find x in any equation. I'm going to take the top equation, it just looks smaller. This time we know what y equals, so this is what we're replacing. So I'm going to get x minus 3y equals negative 17. All right, again, replacing y with a 6. So x minus 18 equals negative 17. We move 18 across, change its sign. These signs are opposite, so I subtract. 18 is bigger than 17, so it's positive. X ends up equaling a positive 1. Y is a positive 6. X first, y second, ordered pair, always for an answer for those problems. That's 3 problems of that type altogether in the test. That's 21 points. So make sure you've got your techniques under control on that so you do well. Next problem. 2x minus 4 times 3x squared minus 4x plus 1. The requirement of this problem is that this object gets multiplied by this entire parentheses. Distributive property for that. So if I do 2x times 3x squared, I'm going to get 6x to the third. 2 times 3 makes 6, x times x squared, you add the powers, get x to the third. 2x times negative 4x makes negative 8x squared. It's negative because the signs are different. 2 and 4 multiply to make 8. X times x makes x squared. 2x times positive 1 makes positive 2x. Then I'm going to take this object, which is negative 4, and multiply it by the entire second parenthesis. Being careful about signs when I do it, this is a negative 4 being multiplied through. Negative 4 times positive 3x makes negative 12x squared. Negative 4 times negative 4x makes positive 16x. Negative 4 times positive 1 makes negative 4. Okay, so we get a total of 6 multiplications. To get the multiplication taken care of, the other step of multiplication of polynomials is that we add like terms. I put my first product here, my second product here, lining up like terms in the process. So I got like terms here and here. 6x cubed has no like terms, nothing happens to it. All you have to do here is make sure you add or subtract correctly based on sign, and then give the answer the correct sign. So these are the same, so I add. Powers do not change when I'm adding or subtracting. A 12 is bigger, so it's negative. These have the same sign, so I add. Again, powers don't change. 2x and 16x make 18x. 16 is bigger, so it's positive. Negative 4 has no like terms. That is the correct answer. From what I've seen in homework, most of you get this. Most of the problems are there's 6 multiplications, you mess up on a sign. Or you see these, you subtract instead of add, that kind of stuff. So I would pay attention to detail on my simplification. I pay attention to my detail of multiplication, that I get the correct signs on each object. So if you get a wrong sign, of course, you're going to do the wrong thing. So be careful you get the correct signs. Be careful you add when you're supposed to add, subtract if you're supposed to subtract. Make sure the sign of the answer matches the sign of the bigger number when you're adding and subtracting. Number 6, polynomial division. We're going to take the dividend in descending order inside a quotient bar. Divided by the divisor outside the quotient bar, also in descending order. The division process is what it has been. We're going to take the first object outside and divide it into the first object inside. And every time we're just dividing by x, so all that happens is whatever this thing is, the power drops by 1. The sign is managed by the signs in the problem. So this is positive divided by positive makes a positive. X to the second power is what you get. Then you multiply whatever answer you get times both pieces of the divisor. X squared times x is x cubed. X squared times negative 1 is negative x squared. That's negative 1x squared if you want to be really technical about it. We get a binomial product. We're going to subtract that binomial by changing both signs. So x cubed becomes negative, 1x becomes positive. And the reason we do that is because now x cubed minus x cubed cancels, getting the highest power term out of the problem. The remaining problem is going to continue on. 2 plus 1 makes 3, x squared. They're both positive, so I add. 2 is bigger, so it's positive. Bring everything else down and perform the task again. So we have first object inside, 3x squared, being divided by first object outside, x. Once again, it's positive divided by positive, so I get a positive. I have to have pluses and minuses after the first term, so make sure those show up. 3x squared divided by x is 3x. We multiply answer 3x times both pieces of the divisor, 3x squared minus 3x. We're going to subtract the binomial product by changing both signs. 3x squared becomes negative, 3x becomes positive. 3x squared minus 3x squared cancels, getting rid of the highest power term. 3x plus 3x is equal to 6x. Addition because the signs are the same. Positive because 3 is the biggest number and it's positive. We got a plus 4 there. As long as we continue to have x down here, we got to keep on dividing. So first term inside divided by first term outside. 6x divided by x. Positive divided by positive makes a positive. 6x divided by x just makes 6. We take answer times divisor, both pieces. So 6 times x is 6x. 6 times minus 1 is minus 6. We're going to subtract this binomial product by changing both signs. 6x becomes negative, 6 becomes positive. 6x minus 6x cancels, getting rid of the highest power term. 4 plus 6 equals positive 10. Addition because the signs are the same. Positive because 6 is bigger than 4. The remainder is positive 10, so I'm going to put a plus sign for my remainder. If it was minus 10, I put a minus sign there. Then I put my remainder term. remainder on top, divisor on bottom. Whatever this is the bottom, whatever this is the top of that fraction. And that is our quotient for that problem. Number 7, same skill. Slightly different because this is missing a couple terms. So the only difference in the setup, I've still got my divisor outside. So x minus 3 is what we're dividing by. So it goes outside. We're dividing into x cubed minus 5. So x cubed minus 5. I left this big gap because x squared and x are going to show up. And the best plan for that is to account for that possibility by sticking in terms that equal 0 that don't have any value. Once we do that, division is what it was in the last problem. I'm not going to change colors on this one. I'm just going to go ahead and go through the process. First divided by first is x squared. Again, whatever this is, drop the power by 1. Positive divided by positive makes a positive. X squared times both pieces. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Binomial product, we're going to subtract by changing both signs. X cubed becomes negative. 3x squared becomes positive. Those are opposites, they cancel. 0 plus 3 is equal to 3. Again, this 0 term had no influence on this whatsoever. It just created space that allowed me to have something to add 3x squared to, so I knew where to put it. Everything else brought down, so plus 0x and minus 5. Go through the process again. First object inside, first object outside, both positive, so I get a positive. 3x squared divided by x drops the power by 1 to 3x. 3x times x makes 3x squared. 3x times negative 3 makes negative 9x. Careful signs, positive times negative makes a negative. Binomial product, I'm going to change the signs to create subtraction. So 3x squared becomes negative, 9x becomes positive. 3x squared minus 3x squared cancels. 0 plus 9x is 9x. We continue to have an x over here, so we continue to divide. 9x divided by x. Positive divided by positive makes a positive. 9x divided by x makes 9. The x just disappears. 9 times x is 9x. 9 times negative 3 makes negative 27. For my binomial product, change both signs. 9x minus 9x cancels. Negative 5 plus 27 equals 22, which is positive. Since it's positive, I put a plus sign. My remainder term is always the remainder value, 22, over the divisor, x minus 3. There is my quotient. So there's 2 problems of that variety. That equals 14 points in your test. So there's still 15 problems, but there's kind of chunks of problems in this test. So really get good at the ones that have multiple problems. Make sure you get those chunks of points. Adding fractions, you guys are getting pretty good at this, so I'm not too concerned at this point. Least common denominator of x and y is just xy. And once I establish the least common denominator, I simply have to modify the numerators appropriately for each fraction. So 5 over x has a denominator of x. I want it to have a denominator of xy. So 5 stays 5. X, y isn't there, y is there now, so y is new. The second fraction, we have 4x over y, so it's plus, so it's still plus, and it's still 4x. It's always what it was, and then you have to modify. So y is still there, x isn't, x is. So x is new, so I'm going to put an x on that piece. So again, what was there, what is there now, whatever is there now that's new goes in the parentheses. X was there, xy is there now, y is new, y went in the parentheses. And then it's simply a matter of simplifying those pieces. So xy is fine. 5 times y is 5y, can't make that any prettier. 4x times x is just going to be plus 4x squared. Do not reduce those fractions. If you get a least common denominator, just assume they won't reduce. If they happen to reduce, I'm not going to count it wrong anyway. So just get your answer, circle it, and stuff. Number 9, a lot of you are having difficulty with this because you're not following the procedure I laid out for you. It's a very simple 4-step procedure. If you do what I told you to do when I tell you to do it, it's not very difficult to do these. But again, a lot of you are getting them wrong because you're skipping a step. Step 1 on the procedure says to write b equals whatever the base is. Immediately. Before you do anything else, write down what the base is, because that's where most people mess up when they do everything else right. B equals 14. The only other piece of information you need to know is what h equals. I'm going to put a little box around these pieces of information here. Once I know both of these numbers, the formula for area of a triangle is 1/2 times the base times the height. So once I know both of these numbers, I simply have to put 14 there and whatever h is there, and I'm going to get my answer. So this part of the problem is really simple. The challenge of the problem is how to find h. But again, start off before you do anything about breaking the triangle apart or whatever like that. Whatever the base is, write it down immediately so you don't try and do something weird with the base. Step 2 of the process. We're going to draw in the height. So we're going to go from the vertex angle of the isosceles triangle straight down to the unequal base. Okay, so the two equal sides on either side go always from the vertex to the unequal base. And you draw that altitude in, or that height, you mark it with an H, and you put a right angle there, or there. It doesn't matter where you put the right angle. Either side. You're creating two congruent right triangles there. And what happens is the base gets broken in half, so 7 and 7. Okay? And going back to what most of you are doing wrong on these, when you do everything else right, you're going to write b equals 7 because you broke the base in half. You're just finding me the area of one of these right triangles instead of the whole area. So make sure, again, for the answer we're looking for, this is the base of the triangle we started off with. That's what we want to use. All I got to do to find out what h is Pythagorean Theorem. I know a leg, I know a hypotenuse, I'm looking for the other leg. So if I do leg squared plus leg squared equals hypotenuse squared, it creates a nice little Pythagorean Theorem equation. 49 plus h squared is equal to 169. Move the 49 to the other side. Subtracting it because I had to move it across the equal sign. That gives me h squared is equal to 120. Which means, therefore, h is going to equal the square root of 120. And I've actually used decimals on these problems. So if I just go ahead and type my calculator, the square root of 120 equals, comes out to 10.95. So 10.95 goes right there. Alright, so I wrote down the base immediately. I used the little Pythagorean Theorem stuff to find the height. Once I know both of these numbers, I simply have to use the triangle area formula that we used back in 6th grade, or 5th grade, whatever grade you first started doing areas of triangles. We didn't have decimals probably in those grades, but again, it's 1/2 times base times height. So area is equal to 1/2 times base times height. As far as typing that in the calculator is concerned, it looks like this. 1/2 0.5 times base times 14 times height times 10.95, and it comes out to 76.65. Unit of length is inches, so it's going to be inches squared. Okay, on the test, you can expect an isosceles triangle with two equal sides and an unequal side on the bottom. I even make the unequal side on the bottom even, so you know, when you divide it in half, you're going to get nice whole numbers here, so your Pythagorean Theorem is pretty easy to deal with. So that's the extent of that problem. That's how you do it. Don't skip steps. Don't try and cut corners on that. Just follow the procedure exactly as it is, and it shouldn't be very difficult. Number 10. I want everybody to focus clearly on the directions, find the distance. Okay, it does not say find the equation line, it says find the distance. How far apart are these 2 points? And usually what we did with these problems is we used graph paper, and I'll supply with graph paper on the test when it comes time to do that. So here's graph paper for this. And find the distance between the points. So I want to plot those points. So I put an x-axis and a y-axis here. I mark them very clearly so I know what's what. The first point is -2, 5. That's 2 left and 1, 2, 3, 4, 5 up. The second point is 5, -3. That's 1, 2, 3, 4, 5 to the right, 1, 2, 3 down. The directions tell me exactly to do this. Find the distance between. So how long is that same segment is the question. So what I'm looking for in this problem is the length of that segment. And the way I'm going to find the length of that segment is I'm going to find out how long this piece is, and find out how long that piece is. Okay, I'm creating a right triangle out of this picture. And the way you find out how long pieces are is you count spaces. 1, 2, 3, 4, 5, 6, 7, 8 spaces for that. 1, 2, 3, 4, 5, 6, 7 spaces for that. D is the hypotenuse because it's opposite the right angle. So 8 squared plus 7 squared is equal to D squared. Pythagorean theorem is what it always has been. Square the leg plus square the leg equals the hypotenuse squared. 64 plus 49 is 113. So D is going to equal the square root of 113. And I would stop right there. If you want to use a calculator to get an approximate square root, I'll take that answer too. The approximate square root of 113, my calculator says is 10.63. So I'd also be fine with D is equal to 10.63. Notice it says D equals, doesn't say D squared equals. D squared equals this, so D equals that. Okay, we're looking for a distance, so the positive square root is the one that makes sense. We wouldn't want to use the negative square root in this scenario. Again, either one of those answers would be fine. If it comes out to a nice whole number, I'd rather the radical be simplified. Square root of 25 equals 5, for example. But if it's going to be a decimal anyway, I'm fine with the radical being the final answer. Number 11 says, find the equation of the line that passes through the points. So notice the directions here. Find the equation of the line. Okay, just like we discussed in class on Friday about finding the equation of the line, the first task of that question is how do you find slope given the information that you have? So in this case, the line passes through points. So I find slope that way. And again, if I use graph paper, we can use the slope formula also, but just staying on the graph paper idea here. Let's see here. Draw an x-axis and a y-axis. Everything's happening kind of over here. My first point is 5, 1. 1, 2, 3, 4, 5, 1. My second point is 4, negative 1. 1, 2, 3, 4, negative 1. My directions are to find the equation of the line. So what I'm trying to do here is find the equation of this line. So instead of finding a distance, the length of this segment, now it says find the equation of the line, so I'm trying to find the equation of the line. To do this, I do find slope by finding rise and run. So, if I'm going from this point to this point, I'm going here and here for rise and run. Okay, I'm starting here, going up to this point, and then I'm going here and just go over to that point. So, always follow the directions, get off the line, then get back on the line. Don't get off the line, meet over here somewhere, get off the line, get back on the line. I'm going up 2 spaces, rise. I'm going right 1 space, run. Okay, both those directions are positive directions. Going up or going right. Going down and left are both negative directions. All right. Just make sure that whichever direction you're going, you get the right sign on that direction. The slope is defined as rise over run. So in this case, 2 over 1. And just like I mentioned on Friday in class, this is a whole number. Let it be a whole number. Okay, get over 1 out of these problems. It gets in there and makes you start thinking about stuff that's not important. So 2 over 1 is just 2. That's the slope of this line. At this point, I'm going to go to slope equals 2. And I need a point, and I've got 2 points. It doesn't matter which point you pick. Pick one of the 2 points. I'm going to take 5, 1. Every find the equation of the line problem, once you've found slope, is the same. They're going to give you at least 1 point every single time. This time they gave us 2. I picked 1. And you found the slope because we went through the process to find slope. Once you found both of these things, then y equals mx plus b is your goal. It's going to create the answer. Y equals 1, m equals 2, x equals 5, 1 equals 10 plus b. 2 times 5 is 10. Again, this is a whole number. Let it be a whole number. Move the 10 over. Becomes negative 10. Minus 9 equals b. I've got a slope of 2. I've got a y-intercept of negative 9. My equation is y equals 2x minus 9. A good constructed equation has a y equals. It has an x. It has a slope. It has a y-intercept. Y-intercept is negative, so I put minus 9 because plus b means to whatever b is, use that sign in your answer. Okay, that's what your final answer should look like on that problem. So 10 was find the distance. That's going to be a number. 11 is find the equation of a line. That's going to be the equation formula for a line. So make sure you're answering the right question. Still on homework, a lot of you are getting this question and giving me a number, finding distance, or getting the distance question and finding me an equation. So both things give us the same information. Point, point, but they're asking you to do different things with it. So make sure you answer the question they're asking you, not what you think you're supposed to do because you see that information. Number 12. Once again, find the equation of the line. So we're looking for y equals mx plus b here. And when I see those 6 words, the first question I ask myself is, how do I find slope for this problem? This one's very straightforward. Has a slope of negative 3/4. There's how you find slope. Slope is negative 3/4. Okay. My point that it passes through is 12 comma negative 2. As soon as I know what the slope is, the next thing I care about is what does it pass through. Okay. Once I know both of those things, I go straight to y equals mx plus b. And I substitute all those numbers in that I know. Y is equal to negative 2. M equals negative 3/4. X equals 12. Okay, I'm just going to come over here real quick and just do negative 3/4 times 12 because I'm still having some of you having issues with multiplying whole numbers times fractions. I'm going to put that 12 over 1 just to create where it's at. It's in the numerator over 1. All right? This happens a lot and you should look for it. The number that's on the bottom of your slope happens to divide evenly with the number that is the x-coordinate of your point. Negative 3 times 3 makes negative 9 over 1, also known as negative 9. Do not put over 1 on the product if it's a whole number or integer. So this piece here is negative 9. So negative 2 equals negative 9 plus b. Again, it's an integer, it's not a fraction. I don't have to deal with that over 1. I don't have to see a fraction to look at this. Negative 9 moves over, plus 9. Negative 2 plus 9 is 7. Equals b, subtraction because the signs are different, and it's positive because 9 is bigger than 2. This time notice b is a positive number. So I know my slope, I know my y-intercept, so my answer is going to be this black equation. X and y are going to be there. M and b get replaced with numerical values. So y equals negative 3/4 x plus 7. Okay, so there's 2 problems finding the equation line. One, you have to find the slope. The other one, the slope's just given to you. Both problems go through this process where you have a slope and a y-intercept, and you have to find out, or sorry, a slope and a point, and you have to find the y-intercept. 13, solving a fractional equation with some mixed numbers involved also. My advice has always been, first off, to deal with your mixed numbers, make them improper fractions. Be careful you do that properly. X belongs in the numerator. 2 times 5 is 10 plus 4 is 14. So 14x over 5 is the equivalent of 2 4/5 x. Minus 2/3 is behaving itself, so it's going to stay minus 2/3. Equals is just equals. And then 19 and 2/15. 19 times 15 is 285 plus 2 is 287. Let me check my math on that real quick. 19 times 15, 285, perfect. Okay, so a little bit bigger numbers that time. So again, if you want to do it in your head, fine. Use a calculator to verify, fine. Or just have a calculator to do it for you, fine. But just give me a correct improper fraction equation here. And then the least common denominator of everything in the problem is 15. When I multiply by a common denominator, divide first, then multiply. 15 divided by 5 is 3. 3 times 14x is 42x. 15 divided by 3 is 5 times negative 2 is negative 10. 15 divided by 15 is 1 times 287 is 287. So you get what you get. All the fractions disappear. And at this point, 42x minus 10 equals 287. I'm going to move the 10 over here. It becomes positive because the sign changes. 42x equals 297. Divide both sides by 42. Okay. It doesn't look like it divides evenly, but I'm pretty sure that 297 and 42 both divide by 3 at least. So divide by 3 on top, I'm going to get 99. And divide by 3 on the bottom, I'm going to get 14. So 99 over 14, that doesn't reduce anymore. 99 is 9 times 11, 14, 2 times 7, they have no common factors. I would be fine with 297 40-seconds. I'm not going to count it wrong for not reducing. I'd probably reduce it for you. Look to reduce things if possible, but I'd rather have a fraction than a decimal though. So give me a fraction answer to this problem if it comes out fractionally. If it comes out to a whole number, fine. But if it comes out to a fraction, leave us a fraction. Number 14, expand. First technique that we have to deal with here is we have to get each of these guys simplified. Negative power, positive power. So the negative powers are bad. 2 to the third on the top belongs on the bottom. It becomes 2 to the third, which is 8. X to the negative fourth belongs on the bottom, and y to the first is already on the bottom. I might make it first power. Everything's on the bottom, nothing's on top, so I'm going to put a 1 up there just to have something up there, because I don't have a fraction with no numerator. X to the fourth y over 4 is perfectly fine the way it is. And 8 over x to the fourth y is also perfectly fine the way it is. Okay, I've noticed some of you see minus signs and automatically start moving things up and down. Negative powers get moved. This is 4 to the first power. This is 8 to the first power. They're both behaving themselves. They're not where they are. They're not out of place. They're where they belong. So, if I go ahead now and do distributive property, I'm going to multiply this times this. When you distribute, make sure you do top times top, bottom times bottom. So, 1 times x to the fourth y makes x to the fourth y. Maybe first if you want. 8x to the fourth y times 4 makes 8 times 4, which is 32. X to the fourth y to the first. When I do this times this, 1 times minus 8 makes minus 8. 8 times 1 makes 8. X to the fourth makes x to the 8th. Y to the first makes y to the second. When you're multiplying letters, you're adding powers. So x and x add the 4s, y and y add the 1s. Final step, reduce each fraction as much as possible. So all I'm going to do here, x to the fourth cancel, y to the first cancel. I'm left with a 32 on the bottom. I'm left with a 1 on top because there is a 1 up there. Make sure that you get 1 over 32. I've seen people in the past put 32 for that piece. Here, 8 on top, 8 on bottom is equal to 1. X to the 8th and y squared are behaving themselves on the bottom. They get to stay right where they're at. There's no extra x's or y's. I've seen people make that 0 because you're subtracting powers here. Why don't you subtract numbers? Because the numbers are numbers. These are letters. The rule about subtracting has to do with letters. 8 divided by 8 makes 1. That is the best answer to that problem. Finally, number 15. This is just a straightforward laws of exponents problem. First thing I deal with laws of exponents is this picture. So everything else is fine the way it is. I'll leave it all in black. So 4x squared is fine the way it is right now. X to the negative 14. Y to the 8th are both fine the way they are. Obviously x to the negative 14 isn't fine, but that's in this step. We don't care about it because we care about this in this step. And the rule says that y and x stay the same. The powers change. 3 gets multiplied by 4 to make 12. Negative 3 gets multiplied by 4 to make negative 12. So that's all step 1 is. You deal with the parentheses issue. Everything else just moves along and you don't do anything to it. Step 2, we deal with negative powers and 0 powers. I got a negative power here and here. Those guys both move. Everything else is right where it belongs, so I'm not going to mess with it. So 4x squared y to the 12th and y to the 8th are all behaving themselves in this step. They have nothing to do with negative powers, so we do nothing to them. The x to the negative 12th on the top moves to the bottom. The y to the x to the negative 14th on the bottom moves to the top. Doesn't matter where you put them, I usually put them at the end. The only thing I might rearrange is if there's a number, I'd move the number out to the front. Next step. I don't want multiple letters in the same top to bottom. So there's too many x's on top. The bottom's fine the way it is. The 4 and the y and 12th are both fine the way they are. So the top needs to be fixed, the bottom's fine the way it is. So all I got to fix in this step is what I got circled in blue. Everything else stays the same in this step. So 4 stays 4, y to the 12 stays y to the 12, y to the 8 stays y to the 8, x to the 12 stays x to the 12. X squared x to the 14th makes x to the 16th. My final step. I don't want to have multiple y's or x's in the problem at all. So at this point, even though this was fine and this is fine, now within the whole problem, there's too many y's and there's too many x's. So, 4 is behaving itself, nothing happens to it. Notice nothing happened to 4 the whole time. 4, 4, 4, 4, 4. That's because it's just 4. There's nothing happening to it. Just leave it alone. All right? Too many y's, y is bigger on top. 12 minus 8 is 4. Too many x's, x is bigger on top. And 16 minus 12 is 4. So 4y to the 4th, x to the 4th, in whatever order you want to put. You put numbers in front, but the x and the y order doesn't really matter that much. That's your Test 5 study guide. Make sure you prepare well for it so that you can perform well on it.